Here we have a problem on logarithm. Okay, let's go to the question. If log base 10 of a positive b over 4 equals to 1 over 2 times log base 10 of a positive log base 10 of b, then a over b positive b over a is equal to. So using the given information, we have to find the value of this expression, that is a over b positive b over a. So now let's simplify this one first. So here we have addition of two fractions with different denominators. Okay, to add these two fractions, what we can do is we can use a cross multiplication. That is, the numerator of the first fraction has to be multiplied by the denominator of the second fraction. That is, a times a is a square, and the numerator of the second one has to be multiplied by the denominator of the first one. B times b is b square. Further, we have to multiply the two denominators, that is b times a. B times a can be written as a times b, that is ab. Okay, now my aim is to get the value of this a square positive b square and this ab. Once I get the values of these two stuff, I can plug in over here. I can get the value of the expression a over b positive b over a. Okay, now let me consider the given equation we have over here. Let me write it. That is log base 10 of a positive b over 4 equals to 1 of times log base 10 of a positive log base 10 of b. Okay, so let me write the stuff on the left side as it is. It is log base 10 of a positive b over 4 equals to 1 of times. Here we have addition of two logarithms with the same base 10. Whenever we add two or more logarithms with the same base, what we have to do is we can take logarithm once with whatever base we have for the logarithms, and we have to multiply these two arguments a and b, then we get ab. Actually, this is a product rule of logarithm. Okay, now let me write the equation, that is log base 10 of a positive b divided by 4. Now I can use the power rule of logarithm. That is, whenever a logarithm is multiplied by some number, so the number can be taken as the exponent of the argument. That is, this 1 over 2 can be taken as the exponent for this argument ab. Then I'm getting a log base 10 of ab raised to the power of 1 over 2. Okay, here two logarithms are equal with the same base 10. Whenever two logarithms are equal with the same base, what we can do is we can equate the arguments. Then I'm getting a positive b over 4 equals to a times b raised to the power of 1 half. Okay, now let me continue over here. We have a positive b over 4 equals to ab raised to the power of 1 half. Okay, now to get of this exponent 1 half, what I'm going to do is I'm going to square both sides of this equation. Okay, let me square the left side, and now let me square the right side. So here we have exponent 2 for a fraction. Whenever we have an exponent for a fraction, the exponent can be distributed for the numerator and denominator of the fraction. Then I'm getting a positive b the whole square over 4 square, and here on the right side we have base ab, and we have the first exponent 1 half, and for this complete stuff again we have exponent 2. Whenever we have two exponents like this, so what we can do is we can multiply the two exponents using the power of a power rule in exponent. So then I'm getting ab raised to the power of 1 half times 2. I just multiply the two exponents we have over here. This 2 will cancel out. Then I'm getting a positive b the whole square over the value of 4 square is 16. On the right side we have ab raised to the first power, that is just ab. Now let me multiply both sides of this equation by 16 to get of the denominator 16 over here. This 16 will cancel out. Then I'm getting a positive b the whole square equals to 16ab. Okay, now we can expand the square of the binomial over here. Then I'm getting a square positive 2ab positive b square equals to 16 times ab. Now let me subtract 2ab from both sides. Let me do it. When I subtract 2ab from both sides, is positive 2ab, negative 2ab will cancel. Then I'm getting a square positive b square on the left side. On the right side, when I combine 16ab, negative 2ab, I'm getting 14ab. Okay, now I got the stuff that is equal to a square positive b square. Okay, now what I'm going to do is I'm going to plug in 14 times ab for this a square positive b square. Okay, let me do it. So we have 14ab for this a square positive b square. Now we can keep this denominator ab as it is. So here this ab will cancel. Then I'm getting 14. So the value of this expression a over b positive b over a is 14. We find 14 in answer choice B. The correct answer choice for this question is B.